Hello, in this video I'm going to be talking about the most common functional groups used in organic chemistry that consist entirely of carbons and hydrogens. The first three compound types I'm going to be talking about look very similar. They're going to be the alkane, alkene, and alkyne. An alkane is simply an R group single bonded to a hydrogen. So an example of an alkane found in nature is going to be propane. An alkene is a carbon double bonded to another carbon, and an example of an alkene found in nature is going to be a propene. An alkyne is a carbon triple bonded to another carbon. And an example of an alkyne would be a propyne. So since they're all three carbon chains, the beginning of the compound name always starts with prop. And the only difference between the three examples that I've drawn actually consists in the ending. And that's indicative of an alkane, an alkene, or an alkyne, depending on whether or not the example has a single, double, or triple bond. The next two compounds I'm going to be talking about are look very similar. However, there is a slight difference that's important to note. The first is going to be a benzene ring. And a benzene ring is a 6-carbon ring that's often drawn with a circle in the middle. And the reason why a benzene ring is often drawn with a circle in the middle is because it really exists as a combination of two different resonance structures. And that's because the pi electrons on a benzene ring are always moving. And so a benzene ring exists as sort of a 50-50 mixture of the two different rings I've drawn in the example box, and the movement of the pi electrons essentially makes the benzene ring a much more stable molecule. Benzene is a very stable molecule for many reasons, and resonance is one of them. So if you see either of these benzene rings drawn, you'll know that benzene really exists as not either of them, but really as both at the same time. The next compound type I'm going to be talking about is a phenyl group. And in a phenyl group, it's basically a benzene ring, except attached to a phenyl group is anything but a hydrogen. So in total, a phenyl group has one less hydrogen attached to the 6-carbon ring. So an example of a phenyl group that I've drawn is chlorobenzene. And chlorobenzene in the picture I've drawn is very stable. All the atoms have a full all the atoms have a full octet. However, it doesn't exist entirely as the example that I've drawn in the picture. It actually exists as a mixture of the 5 different resonance structures that I've drawn here. So really, it's existing as not any single one of these structures that I've drawn, but all of them at the same time. And by the same logic, like the benzene ring, this movement of pi electrons, the double bonds, creates a much more stable molecule.